Hello, Introduction to Java Programming. In this session, we discuss about some of the thread class methods such as sleep, join, current thread, get name, get priority, set priority, etc. Let's begin. So in the previous session, we have seen how to create threads in Java by extending the thread class. Another is by implementing the runnable interface. Now let's understand some of the useful methods in the thread class. So there is a sleep method and which has two forms. So sleep with milliseconds and sleep with milliseconds and nanoseconds. Okay, we can tell sleep for this much time. So this method is used to sleep a thread for some specific time. I say sleep of some 100, so it sleeps for 100 milliseconds. I can say sleep of 500 comma 750, so 500 milliseconds and 750 nanoseconds, like that. And very useful in building the business development. So whenever you are writing an application, so sleep method is so useful actually. So in order to provide a uniform access to all the threads, sleep method is helpful actually. So I will tell you with an example, then you will understand. And there is some join method, which has three forms: join indefinite. So we are not specifying any time, and join with milliseconds, and join with milliseconds and nanoseconds. So whenever join is called on a thread, so it's a non-static method. You will call an thread directly, and sleep is a static method. So we will say thread.sleep. So this join method makes other threads to wait till this thread finishes its job. So kind of prioritizing the job actually, right? And we'll also see an example, good example of this. And then we have a current thread method, which is again a static method. It actually tells the currently executing thread. So what is the thread that is being under execution in the critical section? That is your run method, right? That actually known with the help of a current thread, and very useful method. And by knowing our thread, we can actually do business logic. Since we can give some names to our threads, we can set names and we can get the names. So in the critical section, I will ask for the name of a thread, and based on the name of the thread, then I can actually ask to do a particular job. Okay, so that's the current thread method. And then we have get and set name methods for threads, and get priority, set priority. And each user thread will be given some priority, that is 5. And we can also give some priorities. The maximum priority is 10 and the least priority is 1 actually. So we have some constants defined also. Okay, so let's understand these things with an example. So let me actually take you through my slides here. So sleep method. So we can actually make a thread to sleep for a specific time. And as I told, there are two sleep methods. These are static methods. And whenever sleep method is used, and sleep method can be interrupted. So it declares an exception, interrupted exception. So whenever we are using the sleep method, we should actually keep them in try catch. Otherwise, we have to declare this exception. So that is one thing that you have to do. So I will come back to this. And before that, let me go and tell you the importance of sleep method with an example. Okay, so this is the example which we have used earlier also. Now I have a class multi which extends thread. And this is the critical section for me, the run method. And I have two threads. And these two threads are actually being started by the main thread. Now these two threads are competing to print 1 to 10, right? So when you run, actually, you cannot clearly tell what is the output. You can't tell, so nobody can actually. In fact, nobody can tell what is the output that is going to come. Let's actually see javac multi.java. And when I run actually, java space multi. Now you can see this time 1, 1, 2. So interleaving. So that means they are executing parallelly, right? So whenever the time is given by thread scheduler, they will go and finish the job and come out. So we cannot actually predict the output. So this is the output. Exact output we cannot predict. Next time when I run, now let's see what happened. 1, 2, 1, 3. Next time when I run, so this is something like this, right? So we cannot predict. So some threads are going to the critical section, and thread scheduler allocates some time, and it's the printing and coming out. But now I want to give uniform access. See, for example, the same example I'm discussing. So you want to book a ticket, and there are 1,000 people, 1,000 users who want to book tickets. Now, if I give random time for each user, then it will not be good actually. So some thread go and finishes, some thread just stops. Not like that. So what we do is we will give uniform access. While designing our multi-thread application, we will give some uniform access. So how do you do that actually? Means with the help of the sleep method. So what you do, so you actually here, what we're doing is in the for loop, I made it a block actually. So now here, after printing this number, I want the thread executing the critical section to sleep. So sleep is a static method. Then I will actually say like this, thread dot sleep. So we need to provide time, right? So I want to make this thread to sleep for 700 milliseconds because only one value I have given, then it is a milliseconds, right? Now what happens? See, by just having this thread dot sleep, what is going to happen? T1 will go, let's assume T1 has first gone, and it prints the I and it goes for sleep. So whenever it goes for a sleep means what? It is blocked. Okay, it's not going to execute the critical section because sleep was called in it. It go to the blocked state. When it goes to the blocked state, your critical section is free. Then other thread T2 will go and it also prints the I value. And after that, it also goes to the sleep for 700 milliseconds. Of course, computer works in nanoseconds. Computer will be idle for some time. So whenever T1 actually gets the sleep time is over, T1 will come back and prints 2 and goes actually for sleep. So now clearly I can tell what is actually going to happen here. So T1 goes and prints and sleeps. T2 comes and prints 1. T1 comes back, prints 2. T2 comes back and prints 2. Then T1 and then T2. Like that, now I can clearly tell what is the output. So it will be 1, 1, 2, 2, 3, 3 until so on 10, 10 because I'm giving uniform access to all my threads who are already, who are actually coming over here, right? Yeah, so that is going to happen with the sleep method, and that is the use or usefulness of the sleep method. But here the problem is sleep method throws interrupted exception, right? So for example, if I compile, I will get an exception here. Let me compile and show you that it's going to be an exception. Java C multi.java compiler will not compile it. It says sleep method can be interrupted and it has the capability of throwing interrupted exception. We must actually keep try catch. Okay, so that's what actually. So unreported exception, interrupt exception must be caught or declared to be thrown. So here I cannot declare here because this is my overridden method, right? In fact, what I'm doing here, I'm overriding because my thread class has a run method, but empty implementation, I'm overriding. So when you are overriding, your signature of the method must be same, right? Your method in the thread class has no interrupted exception. Now you cannot throw interrupted exception, right? That's why we cannot declare exception. So what we need to do is we have to keep try catch. So do you get the point? The point here is this is actually run method is a overridden method. I'm not implementing it, right? So in the overridden method, signature must be same. You cannot change the signature, right? So now I'm keeping this in try catch. Yeah, now immediately I'm writing my catch. So just for compiler purpose, I'm doing this. So you catch this exception with your super reference exception E, and here I am just going to say print system.out.println E. Then it is perfect, right? Then it will be perfect and it will get compiled now without any problem. Let's see, Java C multi.java. Yeah, it's compiled successfully now. Let me run now. Now you can predict the output. See 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10. Yeah. So now when you write a book ticket method, now you have to call that book ticket method in the run method. Now whoever users goes, what they will do some work and they will go for the sleep so that other thread will come. Like that, all the thread will finish the job at once. Okay, so that's the importance of the sleep method. So when you are designing, you have to use the sleep method properly. And the sleep method can have nanoseconds passed also. So this is milliseconds and nanoseconds. So first argument is milliseconds. second argument is nanoseconds. So you want more delay, you can actually give more. So let's say this is 1000 milliseconds. So you can see the delay much. And what I do is, so I will create one more thread. Let me have one more thread. Okay, so multi T3 and T3 dot start. Now I have three threads. I have three threads which are competing for my critical section. Now what is the output? Now also I can say it is 111, 111. Then it is 222 because sleep method is used, right? And then 333. So each thread is given the equal opportunity to execute the run method. Okay, so in real time, things will happen this way only. So let me compile this. So now I have three threads. So now I will see 111, 222 like that. Yeah. So let me run now. Now you can see 111, 222, 333 like that. Right? You have 100 threads also. All 100 threads actually equally be taking the time in the critical section. Fine. So this is about the sleep method, and sleep method has two variants. Let me go back to my slide here. So here, just like whatever I'm doing, the same thing we are doing here with the two threads. And a few questions actually here. Can we start a thread twice? So here, this example, I have a thread T1 and T1 dot start, and again I'm saying T2 dot start. Whenever it says T1 dot start, it will be in runnable state. And already it is in runnable state. Again, I'm saying start. So now you are going to get a runtime exception. Compiler has no issue, but at the runtime, you will get exception in thread main. So your main thread is going to get created for every program, right? And there is an exception, abnormal termination. And java.lang. Illegal thread state exception. Already I'm in runnable state, and you are asking me to come to runnable state. So that is illegal thread state exception, right? And what happens if you call run method directly instead of the start method? This I have explained already. Okay, so I'm not saying start, but I'm calling run. So there is no compile time error, there is no runtime error. Because you have not started, it will not have its own flow. It will not have its own flow. It's just like a normal method. Just like a normal method, it just goes and prints running. But you will have no a separate flow. So parallel execution will not be there. Okay, so that's the thing actually. So we have seen already. For example, here I have a run method which is printing 125, and I'm saying T1 dot run, T2 dot run. What happens? Normal method. T1 125 will get printed, and then 125 will get printed later because there's no multi-threading. If multi-threading is there, so these two will continue the execution parallelly, right? Parallel flows of execution will be there in multi-thread applications. For that, you have to start the thread. So start method is so important. Okay, then only your thread is going to become runnable and thread scheduler can pick it. Now it is not started, so thread scheduler will not pick it, right? So it's a normal method. So you have a method, just like any normal method, you have a method and it is going to get executed, right? So now let's actually understand the join method. Yeah, join method has indefinite join, milliseconds, and one more is also there. So that's actually that I will actually explain with my Sublime. Yeah. So let's go to the Sublime here. So what is join method? So join method makes other threads to wait till the join thread finishes its job. So that means if you call a join on some thread, all other threads will wait till this join method finishes its job. That's it. So it can be indefinite join, milliseconds, and nanoseconds. So let me actually tell you here with the same example. Okay, the same example I'm going to do. So here I have three threads, right? Now what I'm doing is T1 dot start. Now what I'm doing, T1 dot join. I'm saying T1 dot join. Okay, so T1 dot join also throws interrupt exception. So whenever I use T1 dot join, now I need to use either try catch or I can declare the exception. So here the join is called in the main method, right? So now I can declare this exception here, no problem. Okay, you need not to have try catch. You need not to have try catch just like here, because Here, run method I cannot change. Signature I cannot change there. But main method, this is my user-defined method. I am not overriding the main method, right? So I can change it. So I'm declaring the exception. So my join problem will be solved. So why this is required? It throws actually interrupted exception. It throws interrupted exception. So that's why we need to declare that exception actually. Fine. Now what is going to happen? So main thread creates, it calls it creates a T1 and T1 is ready and it starts executing. During that time, what this particular main thread will do? Main thread now calls for join, calls join. So join and it also creates the other thread, the T2 dot start, and also starts T3 and starts. So now main thread will be executing parallelly, and T1 which was started, which is started executing, which will be printing 1 to 10. And main thread says join, and while it is printing, main thread continues its execution and creates other thread and it starts it. And while T1 is executing, T3 also created and started. That means all the threads are ready. And T1 is already started working because T1 is working and parallel main is also working. And T2 was started, T2 is also ready. And when T3 started, it's also ready. But what happens here is, even though T1 started and it is sleeping, T1 started and it is sleeping, this T2 and T3 will be waiting to complete, to T1 to complete its job. That's the purpose of the join method. Okay. So what happened? T1 started, T2 started, T3 started, but T1 join method is called. Now, because join method is called, this T2 and T3 will be waiting even though the critical section is available. Because what T1 is doing, it goes to the critical section, prints 1, and it goes for the sleep. When it goes for the sleep, critical section is free. But T2, T3, which are ready, they are not allowed to execute the critical section because join was called on T1. So when join was called, all other threads will be waiting for join to finish its job. They all wait to finish its job. Let's see what is going to happen. So now we can actually tell the output. Okay, because the join is indefinite here. So T1 will print 1 to 10. After that, T2 and T3 will start printing 1, 1, 2, 2, 3, 3 like that. Okay, let's see that. See that here. So this is not the output actually that we are going to get. We are going to get a new output actually. Okay, so let me open my terminal. I think my terminal is somewhere here. Yeah. Java. It's taking some time for compilation. So the purpose of join method, the purpose of the join method is to make other threads to wait till the thread was run the finishes its stop. For this particular program written, the output is going to be uh, T1 has to finish. So T1 it's 1 to 10, even though it is sleeping. And then T2 and T3 will come to the party and they will print one after another. Let me show you that actually. So now T1 printing and sleeping 1000 milliseconds and 500 nanoseconds, but T2 and T3 are not coming up. So after that, so T1 finished the job and T2 and T3 has come up. Right. So this is the use of the join method. This is the use of the join method. So some way you can prioritize your work. So here what we are doing, we are prioritizing the work actually. Right. So this is join with indefinite. So T2 and T3 are waiting till the T1 completes its job. Now what I can do is I can only wait for some 5000 milliseconds. So with the time I'm specifying, so T1 So all other threads has to wait for 5000 milliseconds. So during which the T1 will finish its job, whatever the extent that is possible. Okay, when I say join of 5000, all other threads has to wait for 5000 milliseconds only. That it's not indefinite wait. We are not waiting for T1 to finish its job. We'll wait for some specific time. During that time, T1 could be able to finish, it's okay. Now, definitely it is not going to finish because after printing each value, it is sleeping for 1000 and 500 nanoseconds. Maximum it can do 4 or 5, right? So maximum 5 prints it can do. After that, T1, T2, and T3 will join the party. That means those three are going to get executed parallelly. Let's see that one as well. Okay. Java C multi.java. Okay, so it's taking some time. It's compiled. There's no problem. It's compiled. Let me run. Java is ready. Now what should happen? T1 should print 4 or 5. Yeah. So after that, so now the T2 and T3 also will come to the party because 5000 milliseconds is done. So after printing 5, you can see 116, 227, 338, 449, something like that. So that's the use of the join method. Okay. So when a join method is called, what is going to happen? So all other threads will wait for the thread that calls the join method to die. That means it will complete its job. So you can indefinitely wait, or you can actually wait for such particular time actually. So this is about the join method. So we understood about the sleep method. We understood about the join method. Now let's understand about these methods actually. Current thread, get name, get priority, and set priority. So those are pretty easy to understand. So now here, I just want to uh, set name for the threads. Actually, I can set the name. Okay, so for every thread, I can set the name. So here, for example, T1, I am not setting the name. So if I'm not setting the name, by default, the name is going to be thread-0. Okay, for first thread-0, then it is going to be thread-1. This is going to be thread-2. So now what I'm doing for T2, I'm setting the name. T2 dot set name. Okay, so I'm saying this thread as second thread. And T3, I want to set the name. Let's say I'm saying T3 and setting the name as 3. Okay. So T1 I am not setting. So default name it will take thread-0. Okay. So now I want to print actually these names. So what I do here, whenever they go to the return section, Okay. So now here I would like to print their name. So whatever the thread goes over there, I would like to print their name. So for that, what I'm using is I'm just printing. So system.out.println. Now I'm using current thread. Okay, current thread is a static method. So thread dot now current thread method. Thread dot current thread. So this is the method. So which will actually give me what is the current thread that is getting executed. And I'm asking for the name. See, current thread method will give me what is the currently executing thread. And after that, I'm asking the name. Okay, so now all the 3 threads are going, right? And those names also we are going to see somewhere actually. Okay, so timing, what I do is I don't want to print till 10, I just want to till 5 only. And time being, I want to make my join method sleep for only 3000 seconds. And here, let's say this is 750 milliseconds and 500 nanoseconds. Okay. So yeah, let's see now. So we are joining actually only for, okay, let's say 2500 only. So that 750 into 3, maybe it will print 4. After that, interleaving will happen for all the threads. Okay, so here what I'm doing, I'm using the current thread method also. Whatever the currently thread executing method, that name is going to get come actually. So first we are going to see thread-0 because for thread 1 we have not given any name. So the default name it is going to take. So the default thread name is thread-0, thread-1, thread-2, like that. But T2 I gave a name as second and T3 I gave a name as 3. Right. So first T1 will go to the critical section, and it is actually print its name as, okay. So where is this? I think I have not saved this. Java 23. Yeah, here. Okay, so semicolon is missed. Yeah, now let me compile. Okay, it's compiled successfully. Let's see the output. So output, first it should print the name, and then it should start printing the numbers actually. Right, let's check. Yeah, thread-0, that is the first one. So every time it goes, it actually printing the thread name. Right, after that, if you observe here, thread-01, thread-02, thread-03, thread-04, thread-4 actually. So now what happening? It is sleeping, and again it is coming back. Every time I am printing the name. After printing the 4, now second and third threads also will join the party. So first their names are getting printed, and thread 1 also will come now because it's other threads are waiting only for 2500 milliseconds, right? And every time I'm getting the thread names. So that's the use of current thread. Current thread will actually tell us what is the currently executing thread. So by using this current thread method, we can actually do so many things. Like by using the name itself, we can do some business logic. For example, my thread name is even. I will ask my thread to do print even numbers. My thread name is odd. I will ask my thread to print odd numbers. My thread name is something else. I will ask my thread to do that particular job. Okay, so that's why current thread method is so useful. Now let me write one more thing and show you. So here, system.out.println, I want to show you the priorities also. I want to show you the priorities. System.out.println thread.current get priority, not name. So of course, name should be there, and I want priority also to get printed. So coming to the priorities, so there are priorities are defined from 1 to 10 actually. So 1 to 10 priorities are defined, and the 10 is going to be the max priority, and we have a constant actually. So I can say max priority like this. That is nothing but 10. So we have 5. This is called norm priority. These are the constants. So 3 constants are defined, even though you can give the thread priorities 1 to 10. And 1 is going to be the min priority. You have min priority, max priority, and norm priority. So all user threads. So all the user threads are going to be having the norm priority. That is 5. So user threads means what? The threads which are actually created by the user. The threads which I create over here. Okay. So here we have created T1, T2, and T3. So these are all the user threads, right? We have created, right? So thread.current thread.get priority. So this is going to be 5. So every time the thread comes, it also prints priority, all 5. If I want to set priority, I can say T1 dot set priority of 10. I can set T1 dot set priority of 10 actually. So here what I'm doing, I'm setting the priority T1 dot set priority. So this is the method set priority, and I'm actually saying 10. Otherwise, I can also say max priority. Okay. So this is set and get priorities. Now let me compile this and see, verify whether it is printing user thread priority, that is 5. And when I set the priority, it should actually print me the set priority, that is 10. That also we have to see. Yeah, it's compiled. Now let me execute. So thread 0, what is the priority? 10. Thread 0 priority is 10. It's not 5, even though it is actually 5 initially. But what I did, I set the priority to 10 actually. So thread 0, 10, 10, 10. And for second, it is actually 5. For 3, it is 5. So the user threads by default priority is 5, unless you say some priority explicitly. Understand? So yeah, so that's the use of the current thread method. So you can get the name, you can get the priority. Okay, you can set the priority, you can set the name. All these things can happen actually, right? So this is about the important methods: sleep, join, current thread, and some of the thread methods like getters and setters of the names and priorities. In fact, we have get ID method also, and each thread will be having a default ID. That ID is going to get created. So that ID will be some counter actually. Since you open, then how many threads you have created in the session. So that is going to come, right? So these are some of the methods. Hope you have understood. And in the next session, uh, we will discuss about synchronization in multi-threading. Thank you.